Okay. So now I shall discuss with you three interesting programs. They are related to finding the straight edges of existing in an image, or finding the edge and the parameters of a circle. And if time is sufficient, we shall work with finding the area of two complex configurations and the area between them also. So let us begin with the first one, which is finding the straight edges. For this purpose, in LabVIEW, there is a special, or in IMAQ, there is a special function for that, which is called IMAQ Find Edge-2. To work with this function, you need to input the image of interest here. And also, you have to configure the region of interest, because you need to find the straight edge exactly in a given region of the image. At the output, you will get the image itself with the 2 points coordinates which describe the linear edge. At the output of this function, as you see here, we have an array of clusters with information about the straight edge. I have indexed it. It is indexed. And there I extracted the 2 points of interest, which describe the line or the straight line. So if you go to the front panel, the image which we are interested with is the battery bracket, as you see here. And I am interested to find the line edge in this region here. How I made this? I just draw the rectangle of interest and run the program. Now I have a new line, as you see, with these 2 points describing the ends of this line. The coordinates of these 2 points are found by me here. The upper point here, X and Y, and the lower point, X and Y. If you want to be sure, you put the pointer here in the middle, and you read downwards 525, 100. Here it is 525, 101. It is the same. And for the lower point also you get 527 as estimated here. There it is 526.8 and 290 against 292. Suppose you are interested to find the line edges in this region here. So you need to draw a rectangle in this region and run the program. And now you get another 2 points and the line with the new coordinates of the 2 points describing this edge line. If you go backwards here, now this is not interesting for you. If you are interested again, you have to draw newly, and then you will find a new line, which is practically the same. Suppose we are interested to find the edges here in this region. So I have to draw like this, the rectangle, and run the program. Here is the line of interest only, with these 2 points describing the line. Let us try to find in this area here, and we draw. We didn't find an edge here. Straight edge, no. So the answer is 0, 0, 0, 0. There is no continuous line as an edge here. Suppose we want to find it this way again, as you see, to detect in this region. Does it work? It gives you only this portion straight forward, which is the edge, at the external edge here. It doesn't found it here. So I think the idea is clear. The idea is clear. We can move to the next example. Here we are talking about finding the edge of a circle and finding the coordinates of its center and its radius. To define, of course, if you have a number of circles, you can find also for all. The function for that is IMAQ Find Circular Edge. It is given number 3. Also, the same approach here. You need to feed the image of interest you need to work with, and the region of interest you need to define there the parameters and the edge of the circle. You will get an output here with the cluster data describing the fitted circle, the most near or the nearest circle to the edge circle. So if we go to the front panel again and look, so we have here one circle, another, and a third circle which I have worked with. Let us begin with this one, for example. So we put the pointer approximately in the middle, and then we move externally around it, as you see here. Now it's approximated, and we run the program. Now it is approximated, and we have got the circle parameters. X, Y of the center, and the value of the radius. You remember in the previous lecture, I have found the radius about 18, if you remember. Even though, if I put the cursor here, about the middle as approximation, you will find that it is 189, 138. Here, 189, 137.9. It is practically the same. If we want or interested with this circle here, also we can do the same. So we put the cursor in the middle, and then we try to enclose it. And now run the program. These are the spokes for estimation of the perimeter values. And now we have here an estimation of the center of the area of the circle and the radius, which is equal to 59.6. Remember, I found it previously by eye about 60. It is now 59.6 according to our work here. Use of these functions is really very frequent in real practice because you are always expected to know some information about different circles and their location and their also area. Of course, if you know the radius, now I shall show you how to find it also by calculation if we know in advance the value of the radius. The other example here is IMAQ Extract Curves example. In this example, we have, if we run the program, this is the initial image. As you see, we have two configurations. Here they are clearer shown. The outer configuration and the inner configuration. Those are extracted and drawn by me. Those is the original two. What I am aiming at is to find the area of the whole big white contour and to find the area of the right contour inside it. And afterwards, if it is required, you can find the area between them by subtracting both from each other. Okay, so if we go to the block diagram here, we use IMAQ Extract Curves function. We feed it by the image of interest. At the output, we get an array of clusters here. And this array of clusters, I have indexed it twice with the index 0 and index number 1. Here it is index 0 and this is index number 1. Why this? Because I want to extract information related to this contour. This is index 0 and this is index number 1. So after indexing, I use the function of I don't write it, maybe unbundle by name here, and this is the same unbundle by name. Unbundle by name, I took from it what I am interested of the points at the perimeter of this white configuration. And also I am interested with the points at the perimeter of the second configuration. Now I have two arrays. I introduce them to the array or find area of a polygon, and I get the area of the external and the area of the internal complex configurations. Both areas are here. Area of the external is about 2,174, and the other one in the inside it is 465. Of course, you can subtract them and find the difference. Programmatically, you can do that. What is interesting there also? If we run the program again, and in the front panel, as you see, I have introduced this function here, so I can use it in order to find the area of a circle. Which circle here? I mean the circle which is composed of the external perimeters or pieces of these pieces of the figure. And this is done, as you see, as follows. When I run it, I put the cursor in the middle and try to make, it is already made. Newly, I want to fix it. Now, sorry, it has gone. I have to repeat it quickly. So I want to go back. Now I got it. So I have got there the radius and the points of the circle, of the external circle. Excuse me, I doesn't get it because I have done it quickly. It is do newly. Now it is 3,318 pixels. This is the circle enclosed by this perimeter I am showing you. Notice that this area is higher than the area, of course, enclosed within this wheel, because we are missing these parts of the circle. Well, this is just another way to show you how the things are. Yeah. So here, as you see, because we have two circles, we have two values representing the center of the coordinates, xy in pixels, and xy here we can get also in pixels for the other one. Well, I think this is what I wanted to tell you in this short briefing. Thank you for listening, and goodbye.